Hey you guys, this video is about section 1 for chapter 5. It's kind of just a review. We went over this in class already, but it's for students who were absent or for students who were just a little bit confused. So in this section, we are really just going to look at describing end behavior of polynomial functions. I can classify polynomial by degree and number of terms. I do have a slide that shows you the name by degree and by number of terms. And then down below this last objective, I can graph cubic functions. We will be graphing in section 2. This part of graphing is mainly on, I can graph it by making an XY table. So as long as you're comfortable, making an XY table for any type of function actually, and plugging in -2, -1, 0, 1, and 2, then you'll be all right. So cubic functions look something like y is equal to x cubed plus 2. And all you would do is you would take that -2, you'd plug it in for the x, that's the x, you would cube it, and then you'd add 2 to get your y. So -2 cubed is -8, and then -8 plus 2 would be -6. And then you would go and you would plot that point. And you would continue on until you have 5 points, and then you would graph it. So we're not going to really look so much at that either, since it's just making an XY table. All right, so here's the chart I was talking about, where here's our degrees, here's the name using the degree. I gave an example of each one. This number of terms is the number of terms of my example. Here's one term here, and here's the name by number of terms. So again, if this was a quiz and I gave you this polynomial example and I asked you to classify it, I would want you to classify it as a linear binomial. Always tell me the name using the degree first and then the name using the number of terms second. Notice for degrees it only goes up to 5, so anything after that, like 6, we would just say that's a 6th degree polynomial or a 6th degree monomial, however many terms there were. Same thing over here for name using number of terms. Notice we only go up to 4. So 4 or more is called a polynomial. So I'm just going to add that. I'm going to say 4 plus. So anything more than 4 is just going to be a polynomial. All right. So this main section, though, was about end behavior. This is the chart that I wanted you to copy in class. So if you're in class, hopefully you already have it. And if not, get it down now. End behavior talks about these arrows at the ends of our graph. All of our graphs always have 2 arrows, and these arrows are our end behavior. So end behavior all depends on the degree of the polynomial and the leading coefficient. With leading coefficient, that's going to be the number that's in front of your variable, the very first number, your very first coefficient, when it's in standard form. So you want to make sure that you realize it's your lead coefficient when in standard form. I don't have much room up here, but in standard form. All right, and all we care about that lead coefficient is whether or not it's positive or negative. I said in class to keep in mind the phrase positive people. Well, positive people, they bring me right up. So right up. Our arrow, our right arrow, this is the right side, this is the left side. Our right arrows will always be up if our leading coefficient is positive. So in this example down here, the lead coefficient is a positive 1 because this is in standard form. It goes in decreasing order of exponents. 1's positive, so a positive leading coefficient, the right arrow is up. Positive people bring you right up. And it doesn't matter for what degree it is. If your degree is even or odd, positive people bring you right up. They bring you right up. If your leading coefficient, though, is negative, so in this second example, this is in standard form. It goes from degree 2 to degree 1, so descending order. Our lead coefficient is a -1. Negative people bring you right down. Yeah, they're bummers. They're mood killers. They bring you right down. They're downers. So negative people, they bring you right down. Again, it doesn't matter what degree it is. It could be an even degree or an odd degree. Negative people bring you right down. So now that we have the right side cleared up, we have to figure out what's going on the left side. And that is where our degree comes in. If our degree of our polynomial, which is the highest exponent of the polynomial, if it's even, then your arrows do the same thing. They go in the same direction. So for this example, our highest exponent of our polynomial is this 4. 4 is an even number. Since it's even, if the right was going up, then the left is going up. And they are. They're doing the same thing. Versus if you have an odd degree. So look down here. We have an odd degree over here. Our exponent here is a 3. Exponent here is a 3, a 1, and none. So the highest degree of this polynomial is the 3. That's an odd number. Odd is opposite. They go in opposite directions. So in this example, our lead coefficient is negative 0.3. So the lead coefficient is negative, and negative people bring you right down. But since it's an odd degree, odd is opposite. So if it's right down, then your left side is going up. It's doing the opposite of your right. So if you know this chart, it's pretty easy. Even is the same direction. Odd degree is opposite direction. Positive people bring you right up. Negative people bring you right down. The last part of the lesson is how to sketch the graph. Now we know the end behavior. We need to know, well, what kind of shape does it have? Is my graph going to just have one curve in it? Or is it going to have two of these curves in it? Or will it just have a little simple curve? We can decide that by how many turning points our graph has. That's what we call these points that turn. Because if you were a little person and you were walking along this graph right here, well, you would say you're walking downhill. Downhill, downhill, downhill. Oh, but now you've turned and now you're going uphill. That's a turning point. This point right here, that's a turning point. You were going down, but now you're going up. We need to determine how many turning points does a graph have. And that way we know the shape of it. So up here, it says the graph of a polynomial function of degree n has at most n minus 1 turning points. So that's the maximum amount of turning points it can have. You take the degree, you subtract 1. So down below, looking at this graph right here, this is the graph of a cubic function, such as y equals x cubed minus x squared. So we would take the degree, which was 3, minus 1. That gives us 2 turning points. And in fact, we do have 2 turning points. It goes on to say that the odd degree, if your degree is odd, like ours was, then you have an even number of turning points always. And we did. We had 2. It's an even number. If you have an even degree, then you'll have an odd number of turning points. Now, these words up here, at most, it says at most because sometimes you won't have that many turning points. For example, in this one right here, the equation for that would be something like y equals x cubed. Well, you would think that our degree, since our degree is a 3, that 3 minus 1 would give us 2 turning points. But if you notice and if you follow that graph, we're going up, 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 and we keep going up, up, up. We never turn. So there's 0 turning points here. That's because this is a special case. Notice in this equation, there's only one x, x cubed. But over in this equation, there's 2 x's, x cubed and x squared. The special case is when you only have one x. That doesn't mean you couldn't have a constant. This could say plus 2, but that plus 2 doesn't have an x. So this would be a special case where you wouldn't have the most amount of turning points. You would have less than that. So in this case, we have 0. So notice that we should have had 2 turning points, and instead we have 0. We can't have 1 turning point ever when you have a degree of 3, because 3 is an odd degree, and odd degrees have even number of turning points, and 1 is not possible. So notice here, this is a linear, so a degree of 1, and there's no turning points because 1 minus 1 gives us 0. Here, you know this is a quadratic, so a degree of 2, and 2 minus 1 gives us 1, so we have that 1 turning point. But over here, this is a special case where here we have 0, but over here we have 2, even though they're the same degree. If we had a special case, and I'll write it down below, such as x to the 4th plus 2x cubed. Let's look at this first. This is not a special case because there's another x in here. Well, since we have an even degree and our lead coefficient is positive, then we know our end behavior is up and up. Positive people bring you right up. Because our degree is 4, then 4 minus 1, that gives us 3 turning points. So our graph would look like this. Something along those lines, like a W. Now, for a second, if we had the graph y equals x to the 4th plus 2, and it didn't have that x cubed, well, that is a special case. We still have even and positive, so we still have up and up, but in this case, instead of having 3 turning points, we're only going to have 1 turning point. And our graph would look something like this. So it's not quite a parabola, but there is a turning point. We're going down, now we turn to go up. We curve, but we're still going up. So it can't look like a parabola because it's not a degree of 2, but it doesn't have more than 1 turning point like it's supposed to. All right? These are just 3 examples. You're more than welcome to try them. We did them in class, and that's it for this video. This was just a review in case you needed some extra help. I hope this did help you guys. If not, see me for further questions. All right? Have a good one. I'll see you in class.